So the question is find the area of sector of a circle if. So they have given us three different sub-questions. So the first one is where they've given us the radius of the circle to be equal to 15 centimeters and the central angle of the sector to be equal to 60 degrees. So the formula for finding out the area of the sector of the circle is area of the sector of a circle is equal to half r square theta. Note that in this formula, theta is always in radians. So we have the value of r, which is 15 centimeters, and the value of theta, that is in degrees, that is 60 degrees. So first we have to convert this angle in degrees to radians. So let us do that first. So for that, for all, pi radians is equal to 180 degrees. So therefore, how much is 60 degrees in radians? So let this be x. When we cross multiply this, we get pi radians into 60 degrees divided by 180 degrees. So degree unit and degree unit cancel out each other. 0 and 0 cancel out each other. 6 into 3 is 18. So we have the value of theta to be pi by 3 radians. Next, let us substitute this value of theta and value of radius in this formula for finding out the area of the sector. So therefore, area of sector is equal to half r square theta, which is equal to half, where they've given us the radius of the circle to be equal to 15 centimeters. So 15 into 15 centimeters into theta in radians, that is pi by 3 radians. So 3 into 5 is 15. So 15 into 5 is 75. Pi divided by 2 centimeter square is our final answer. This is the exact answer. In order to find the approximate answer, we can substitute the value of pi approximately equal to us 22 by 7. When we do that, we get area of the sector of the circle is equal to 75 divided by 2 into 22 by 7. So here we can divide 2 into 11 is 22. So we get 117.8571 centimeter square. So therefore, our final answer is area of the sector of the circle is equal to 75 pi by 2 centimeter square, which is approximately equal to 117.8571 centimeter square. And our next question is where they've given us the radius of the circle to be equal to 5 centimeters and S is the arc length of this sector, which is 30 centimeters. So first let us write down the data. So radius of the circle is 5 centimeters and the arc length is equal to 30 centimeters. So the formula for finding out the area of the sector is half r square theta. So they've given us the value of radius as 5 centimeters. So instead of giving the value of theta, they have given us the value of s. So for that, we can use the formula for finding out the arc length, that is for all s is equal to r theta. Note that in these two formulas, theta is always in radians. So first, let us find out the value of theta using this equation of arc length, that is for all s is equal to r theta. So therefore, theta is equal to s divided by r, which is equal to 30 divided by 5. So 5 into 6 is 30. So therefore, we get the value of theta to be equal to as 6 radians. Next, let us substitute the value of theta and radius in this formula for finding out the area of the sector of the circle. That is for all, area of the sector of the circle is equal to half r square theta. And in this formula, theta is always in radians. So therefore, area of the sector is equal to half r square theta. R they've already given in the question, that is 5 centimeters. Therefore, 5 into 5 into theta, which we have already found out to be 6 radians. So into 6. 2 into 3 is 6. So we get 15 into 3, which is equal to 75 centimeters square. So the unit is in centimeter square because they have given us the radius in centimeter. So therefore, our final answer is area of the sector of the circle is equal to 15 centimeters square. So in the next question, they have given us the central angle to be equal to as 120 degrees and the arc length to be equal to as 40 centimeters. Formula for finding out the area of the sector is half r square theta. So note that in this formula, theta is always in radians. So in the question, they have given us the theta in degrees. We have to convert that to radians And next, they have not given us the value of radius directly. Instead of that, they have given us the arc length. So using the arc length formula, that is for all S is equal to r theta, we can find out the value of radius. And note that in this formula also, theta is always in radians. So first let us convert our theta in degrees to radians. That is for all pi radians is equal to 180 degrees. So therefore, how much is 120 degrees in radians? So let this be x. When you cross multiply this, we get x is equal to pi radians into 120 degrees divided by 180 degrees. So degree unit cancel out each other. 0 and 0 cancel out each other. 6 into 2 is 12. 6 into 3 is 18, which is equal to 2 pi by 3 radians. So this is our value of theta in radians. Next, let us substitute value of theta in radians in the arc length formula. That is this one, and find out the value of radius. So therefore, for all S is equal to r theta. So in order to find out the value of radius, we can rearrange this equation as s divided by theta. So therefore, r is equal to s, which they have given to be equal to as 40 centimeters. So 40 centimeters divided by theta in radians, which we have already found out, that is 2 pi by 3 radians, which is equal to 40 into 3 divided by 2 pi. So 2 into 2 is 4. So we get 60 by pi centimeters. So next, let us substitute the value of this r and theta in radians in the area of the sector formula to find out the area of the sector. That is for all S is equal to half r square theta, which is equal to half r square, which we have found out to be 60 by pi. So 60 by pi into 60 by pi into theta in radians, which is equal to 2 pi by 3 radians. So pi and pi cancel out each other. So 3 into 20 is 60 and 2 into 30 is 60. So therefore, we get the area of the sector to be equal to as. So 30 into 20 is 600. 600 into 2 is 1200 by pi centimeter square. So this is the exact answer. In order to find the approximate answer, we can substitute the value of pi to be approximately equal to as 22 by 7. When we do that, we get the value of area of the sector to be equal to 1200 by 22 divided by 7, which is equal to 1200 into 7 divided by 22. When we do the calculations, we get 381.8182 centimeters square. So this is the approximate answer. Therefore, area of the sector of circle is equal to 1200 by pi centimeter square, which is approximately equal to 381.8182 centimeter square. So this will be our final answer. So whenever they ask questions related to area of the sector, so there are only three types of questions which they can ask. First, let me write down the area of the sector formula. That is for all area of the sector is equal to half r square theta. First scenario is they will give us the value of r and theta directly, and the given value of theta here will be in radians. Note that in this formula, theta is in radians. When they ask these types of questions, we can directly substitute the value of r, that is r square, and theta in radians, that is theta, and find out the value of area of the sector. Next type of question which they can ask us, they will give us the value of r and they will give us the value of theta in degrees. So for example, let us take the value of theta in degrees to be equal to as 60 degrees. So when they do that, we can use the technique for all pi radians is equal to 180 degrees. So therefore, how much is 60 degrees in radians? So let this be theta in radians. When you cross multiply this, we will get theta in radians to be equal to as pi radians into 60 degrees divided by 180 degrees. So when we do this, 0 and 0 cancel out each other. Degree unit and degree unit cancel out each other. 6 into 3 is 18. So we get the value of theta in radians to be as equal to pi by 3 radians. Now we have the value of theta in radians and they've already given us the value of r. Now we can easily substitute the value of r and theta in this formula, that is area of the sector is equal to half r square theta. So now when we substitute the values, we can easily find out the value of area of the sector. Third scenario is they will give us the value of r, and instead of giving us the value of theta, they will give us the value of arc length, that is they will give us the value of s. When they do that, we can use the arc length formula for all. S is equal to r theta, And we note that in this formula, theta is always in radians. Now in the question, they have given us the value of r and they have given us the value of s. When you substitute these two values here, we can find out the value of theta. And when we rearrange this equation, we get theta to be equal to s divided by r. And the obtained value of theta here is in radians. So now we know that for all, area of the sector is equal to half r square theta. R they have already given in the question, and theta in radians we have already found out here. So now we can substitute the value in this equation and find out the value of area of the sector. The fourth scenario is they will give us the value of theta, and instead of giving us the value of radius, they will give us the value of arc length. When we look into the area of the sector formula here, we have the value of theta, and we can substitute the value of theta in radians here, and instead of giving us the value of radius, they have given us a value of arc length. So now we can use the formula for arc length, that is for all s is equal to r theta. So in order to find the value of r, we can rearrange this equation to be as r is equal to s divided by theta. And note that in this formula, theta is always in radians. So in the question, if they have given us the value of theta in radians, it is fine. If they have given us the value in terms of degrees, we can use the same technique which is shown here. That is, for example, let us take the value of theta in degrees to be equal to as 30 degrees. For all, pi radians is equal to 180 degrees. So therefore, how much is 30 degrees in radians? That is theta in radians. So when we do the cross multiplication, we will get theta in radians to be equal to as pi radians into 30 degrees divided by 180 degrees. So degree unit cancel out each other. 0 and 0 cancel out each other. 3 into 6 is 18. So we get the value of theta in radians to be equal to as pi by 6 radians. So now we have found out the value of theta in radians. Next, we have to find out the value of r using the arc length formula. R is equal to s by theta. Next, we will substitute the value of s, which they have given in the question, and theta in radians, which we have found out, and then find the value of r. Next, we can find out the area of sector. In the question, they have given us the value of theta. So they may give the value of theta in degrees or radians. When they give it in degrees, we can convert it into radians by following this technique. If they've given the value in radians, we can directly substitute it here. And r we have found out by using the arc length formula. Now we can substitute these two values and find out the value of area of the sector. So these are the 4 types of common questions which they might ask. Hope you understood the concept well. Subscribe the channel and like the video. Thank you.